Hi everyone, I am Whitroy. Welcome to this audiobook learning video.
Hi everyone, my name is John and I work alongside Whitroy as an electrical tutor.
In this video, we will introduce ASNZS 4836, which covers safe working on or near low voltage and extra low voltage electrical installations and equipment. Before we begin, I want to make something clear about this audiobook. This is not a word-for-word reading of ASNZS 4836-2023. The standard itself must always be read and followed exactly when you are doing electrical work or preparing for the EWRB exam. The official standard is the legal and technical reference. If there is any difference, missing detail, or possible mistake in this audiobook, you must follow the official document. What this audiobook does is take the key ideas from the standard and explain them in simple spoken language, the kind of language you can listen to while driving, working, or revising. It helps you understand what the clauses mean, why the rules exist, and how they apply in real electrical work. So please think of this audiobook as a learning companion, not a replacement for the actual standard. All right, let's get started.
Section 8. Safety Equipment and Tools. Today we're moving into Section 8, ASNZS 4836. This section is about safety equipment and tools. The main idea is simple. Safety equipment only protects people when it is suitable, maintained, tested, inspected, and used correctly. A damaged insulated tool may not protect you. A faulty barrier may not separate you from danger. A damp or dirty ladder may become conductive. A damaged insulating mat may not provide the protection you expect. So, before using safety equipment or tools, always check that they are suitable for the work and in good condition. Clause 8.1. General. Clause 8.1 explains the general requirements for safety equipment and tools. All safety equipment and tools must be regularly maintained and tested. They must also be visually inspected before every use. If they are found defective, they must not be used. They must be tagged as defective and removed from service. In simple terms, do not take a chance with damaged safety equipment. If an item looks cracked, broken, worn, contaminated, loose, burnt, damaged, or doubtful, do not use it. Tag it. Remove it from service. Then use equipment that is safe and suitable for the task. For work on or near exposed energized conductors or live conductive parts, the requirements for that type of work must also be considered. Clause 8.2. Insulated tools and equipment. Clause 8.2 explains insulated tools and equipment. Insulated tools and equipment must be of an approved type. They must be in good working order. They must also be regularly maintained and tested. They must not be used if there is any doubt that their insulation may fail. In practical terms, do not assume a tool is electrically safe just because it has a plastic-looking handle. It must be the correct insulated type for the work. The insulation must also be in good condition. If the insulation is cut, cracked, worn, loose, melted, contaminated, damaged, or uncertain, the tool must not be used for electrical safety work. Insulated tools are part of the protection system, but they only work as protection when they are the right type and in the right condition. Clause 8.3. Portable electric tools. Clause 8.3 introduces portable electric tools. Portable tools are common on electrical work sites. They may include drills, grinders, saws, lamps, test equipment, and other powered equipment. These tools can create electrical risk, especially where there is damage, dampness, construction work, concealed wiring, or contact with exposed conductive parts. So, the tool, the supply method, the protection device, and the work environment must all be considered. Clause 8.3.1. General. Clause 8.3.1 explains the general preference for portable electric tools. Battery-powered tools should be preferred to mains-powered tools because they reduce shock risk. In simple terms, when a suitable battery-powered tool can do the job safely, it is usually a safer option than using a mains-powered tool. The clause also refers to standards for portable electric tools. ASNZS 3760 covers in-service safety inspection and testing of electrical equipment. ASNZS 3012 covers portable electric tools used on construction and demolition sites. The relevant authority may also have additional requirements. So, when using portable tools, workers must follow the standard, workplace rules, site rules, and any legal requirements that apply. Clause 8.3.2 Protection. Clause 8.3.2 explains protection for portable electrical tools, appliances, and equipment. Portable electrical tools, appliances, and equipment must be supplied through an RCD or through an isolating transformer. RCD means residual current device. An isolating transformer must comply with the ASNZS 61558 series. The secondary winding of the isolating transformer must not be connected to the primary winding or earthed. When portable RCDs or isolating transformers are used, they should be placed as close as practicable to the point of supply. For example, they should be at the supply end of an extension lead, not at the appliance end. This is important because the extension lead also needs protection where practicable. An RCD does not protect against every electrical danger. An RCD may not protect if there is no current path to earth. It may not protect if the tool contacts another source of electricity, such as a drill bit hitting a hidden live conductor inside a wall, floor, or ceiling. It does not protect against electric shock or electrocution between the electrode and return leads when welding. It may not protect where the current leakage path is from active to neutral or from phase to phase. It also does not provide protection for a portable electric tool supplied from an isolating transformer or isolated winding generator. An RCD does not prevent electric shock in every situation. It is designed to reduce the likelihood of electrocution by disconnecting the supply when the right type of fault current is detected. The type of supply and the type of RCD also matter. An isolating transformer also has limits. It does not provide protection if the secondary winding is earthed. It does not provide protection if the tool contacts another electrical source, such as a concealed live conductor. It does not protect against electric shock between welding electrode and return leads. It also does not protect where the leakage path is between live conductors. In simple terms, RCDs and isolating transformers reduce risk, but they do not remove all risk. They must be used together with good work planning, correct tools, correct testing, and awareness of concealed conductors and other sources of supply. Clause 8.3.3 Risk of exposed conductive parts becoming energized. Clause 8.3.3 explains the risk of exposed conductive parts on portable tools becoming energized. Extra care is needed when using portable electric tools or equipment that have exposed conductive parts. These conductive parts may contact exposed energized conductors or live conductive parts. One common example is drilling or cutting into concealed conductors inside a building structure. The metal drill bit, saw blade, chuck, or other conductive part may contact a live conductor. That can make the tool dangerous and may expose the worker to electric shock. Chuck keys tied to portable drills can also create risk if they contact exposed energized conductors or live conductive parts. In practical terms, before drilling, cutting, fixing, or penetrating a wall, floor, ceiling, or structure, think about hidden wiring. Do not rely only on where you think the cable should be. Check, scan, assess, isolate where needed, and control the risk before the tool is used. Clause 8.4. Ladders and stepladders. Clause 8.4 introduces ladders and stepladders. Ladders are often used for access during electrical work, but ladders can increase both electrical risk and fall risk. If a worker receives even a small electric shock while on a ladder, they may lose balance and fall. So, ladder selection, ladder condition, and ladder use must be considered carefully. Clause 8.4.1. General. Clause 8.4.1 explains the general requirements for portable ladders and platforms. Portable ladders and platforms must comply with the relevant ladder standards or an equivalent requirement. They should also be used in accordance with the instructions for use. Ladders are the least preferred option for working at height. This does not mean ladders can never be used. It means that safer options should be considered first where practicable. A work platform, scaffold, elevated work platform, or another controlled access method may provide better safety for some tasks. In simple terms, do not choose a ladder just because it is quick. Choose the access method that is suitable and safe for the work. Clause 8.4.2. Use of electrically conductive ladders. Clause 8.4.2 explains the use of ladders near electrical installations or equipment. Non-conductive ladders must be used when working on or near electrical installations or equipment. A conductive ladder can create a path for current. This can increase the risk of electric shock or electrocution if the ladder contacts live parts or if the worker bridges between the ladder and electrical equipment. The clause also reminds us that ladders that are damp or dirty can become conductive. So, a ladder that is normally non-conductive may still become dangerous if it is wet, muddy, contaminated, or damaged. In simple terms, check the ladder before use. Check the material, check the condition, check for moisture, dirt, damage, and contamination. Do not use a ladder around electrical work if it may become part of the electrical path. Clause 8.5. Insulating barriers, covers, and mats. Clause 8.5 introduces insulating barriers, covers, and mats. These items help separate people from energized electrical equipment. They can reduce the chance of accidental contact with live parts. They are useful controls, but only when they are suitable, correctly rated, correctly placed, and in good condition. A barrier, cover, or mat must not be treated as safe just because it is present. It must be the right item for the voltage, the work situation, and the hazard. Clause 8.5.1. Barriers. Clause 8.5.1 explains barriers. Barriers must be made from material that effectively separates a person from adjacent energized electrical equipment. Barriers must be visually inspected for defects before and after each use. If a barrier is defective, it must be tagged and removed from service. Warning signs should be placed beside barriers or form part of the barriers where barriers are used to prevent accidental access to areas where electrical work is being performed. In simple terms, a barrier has two jobs. It provides physical separation. It also communicates danger. It helps stop people from entering the work area by mistake, and reminds them that electrical work is being carried out nearby. Clause 8.5.2. Insulating covers and mats. Clause 8.5.2 explains insulating covers and mats. Insulating mats used with electrical equipment rated below 650 volts must comply with and be tested according to ASNZS 61111. Insulating covers used with electrical equipment rated below 650 volts must comply with and be tested according to AS 4202. Insulating mats and covers must be visually inspected for defects before and after each use. If they are defective, they must be tagged. In practical terms, insulating mats and covers must be checked carefully. Look for cuts, cracks, holes, contamination, hardening, burns, damage, or anything that could reduce insulation. A damaged insulating mat or cover may give a false sense of protection. For voltages above 650 volts, other standards may apply. So the worker must select the correct insulating cover or mat for the voltage and the task. That brings us to the end of Section 8 of ASNZS 4836. This section reminds us that safety equipment and tools must be suitable, maintained, tested, inspected, and used correctly. Before using tools or safety equipment, check them. If they are defective, tag them and remove them from service. Use approved insulated tools. Prefer battery-powered tools where suitable. Use RCD or isolating transformer protection for portable electric tools where required. Use non-conductive ladders near electrical work. Use barriers, covers, and mats that are suitable and in good condition. And never let damaged or unsuitable safety equipment become the weak point in the work method.